is graph shifts. Okay? Graph shifts. What I'm doing is I'm recording what I have on the doc cam. If you're looking up at the...
You should show the class though.
Okay. Here's the class. Wave! Yeah. Okay.
Is that even on? I think you need to get my signature. It's live. Come in. Sorry.
Wait, so pause it and then we'll stop the time, right?
Okay, so resuming to what I was talking about. This is going to be for all memory graphs. I'm going to shift memory graphs. Now, if you have something inside parentheses with the x, it would look something like this, like x minus, like any number like h. Okay? What this is a horizontal shift of opposite h. Outside parentheses from x is when you have something that just looks like x plus a number k. This is a vertical shift of k. These h and k's are any number, okay? They're going to be our whole numbers. So for example, if we have y equals parentheses x plus 2 squared minus 3, what we already know from the memory graphs is that this is a parabola. We know that because we have an x squared involved. In addition, we also know that it's a positive parabola, so it's upward facing. So those are the things that we know, okay? But what you now know is where it's going to be shifted. Opposite of h. So this is my h. My h is plus 2.
Go left 2.
So it's opposite of 2, which is negative 2. hk will equal negative 2 and right, the same as k, so negative 3. What if I gave you something a little bit more tricky? So like y equals ln x plus 2 minus 3. What is my hk? Somebody? Negative 2, negative 3. You like that? You see how it's...
How's that inverse?
This is ln. I'm not looking at inverse.
That's just telling you what your graph looks like.
It's telling you, what hk is telling you is where you're shifting. It's your starting point, right, of the graph. Like the center of a circle. Okay? Ryan? Or Sam, sorry. You just answered your own question. Okay.
It's not inside the parentheses.
Right, right. Inside parentheses and outside parentheses is like the easy way to know how to do this. Okay?
So I was like, isn't it positive 3? But
Parent graphs. Parent graphs. And it's just what it says it is. A parent graph is the original graph before shifting it. So if I said, what is the, so I'm going to abbreviate parent graph PG. What is the PG of the parent graph of this would be the original function before shifting. So the parent graph is the memory graph without shifts, without any shifting. Okay? So from our example up here, what would be my parent graph? Right, y equals x squared is the parent graph. Okay?
Do you have to graph them or just tell you what?
You'll have to graph the parent graph. Right. You'll be required to graph the parent graph, or whatever it may be. Okay?
Can you graph the ln one for me?
So going back, you would like me to graph this up here? Okay. You know that, let me first do ln of x, my parent graph. Okay? ln of x looked like this off your memory graph. Okay? But that was because at 0, it is approaching 0 right here.
So are we shifting the asymptotes?
Exactly. We'll be shifting the asymptotes. And I'll talk about that next, actually, asymptote examples. But now, it's shifted to the left, -2, right? And
From 0.
and up 3, right, from 0. So, and then down 3, but that's not really going to change the graph too much. Okay, I have ln, this down 3. So it would look something like this.
What? So then 3 doesn't matter? So does it go through?
It didn't, right. That's called the asymptote, and we'll talk about that, how to find asymptotes in a second. Natural log.
Why is it 0, not like a -3 or something?
That's just a guesstimation. You don't have to be specific there.
But, so
Morgan?
could we put it on the -3 then? So what is 3? What's the
To cross the -3?
Yeah.
Sometimes the k, that -3, doesn't change the graph a whole lot, okay?
But why didn't it change it to -3?
Because natural log of x doesn't have any vertex, doesn't have any center, or really designating starting
So then we don't
point.
need to have the dot on the 0 then.
Right.
How do you know it goes to the 0?
Okay.
I didn't, I don't
You just,
know.
like, randomly just-
I just randomly chose, so you don't know that it goes to the 0.
So if we had something like that, you would accept that? Sweet.
Tanner,
Natural log one, so it says y equals natural log x plus 2 minus 3. It's supposed to be x plus 2 squared, or you just have to go to x plus 2.
just x plus 2. Because if you remember, well look, remember your parent graph or your memory graph was just ln of x. Alright, so this was never squared. That's why this is never squared. Okay?
So what squared? ln of x.
Then it would be 2 graphs. It would be a parabola and a...
No, it would just change the zeros actually.
So it'd be one of those examples?
There won't be one of those, okay? That's going out there on a limb a little bit. Okay, so the last thing I'd like to cover.
I'm so lost. Like, I don't know.
Are you taking notes? Yeah? Are you lost, Elise?
No, I'm fine with the like whole ln squared stuff.
Well, just don't worry about it. If you're understanding my examples, then you'll be fine. You'll be fine. I would add this to your word bank. Unless you absolutely understand what it is. So the way I like to define it, a line that is dotted, and let me put in parentheses, it's not a part of the graph. It's dotted, not a part of the graph, that the function approaches. So, to explain the rest of it, or one of the aspects of asymptote, I will use the basic function 1 over x. So, this brings me to my first aspect of an asymptote. When a denominator is undefined, there you have an asymptote.
It's like a little side note.
Yeah. And this is used to define asymptotes.
So we should put that on the one thing too.
It's part of the definition, yeah.
7.5, 7.85. So that's just our units. Whatever units it is, this part, this 12.5,
So where is this at denominator undefined at? No, where exactly? As 0. You can't have 0 in the denominator, right? So at x equals 0, you have an asymptote. Okay? If I were to graph 1 over x, it's one of your memory graphs, correct?
Yes.
It looks something like this. Okay? This is what it looks like. This asymptote, right here, the vertical ones. Can somebody tell me how you represent an asymptote? A dotted line, but then as an equation.
I know that, but I'm just kidding.
No. This asymptote is x equals 0. The vertical ones are.
X greater than or equal to 0. No, x greater than 0.
No, the asymptote itself is a line. Okay. No, that's inequality. Don't worry about inequalities with asymptotes. It's just simply a line.
X equals 0.
Now, do you see any other asymptotes here on this graph? Y equals 0, right. That is found you can also find asymptotes just simply by graph observation. Okay? The last way to find asymptotes is, have you heard of the have you heard of the term a limit?
Yeah.
Yeah. So the limit as x goes to infinity of 1 over x. Does anybody know that? Does anybody know that?
He told us.
He would tell you?
You told us.
Oh. Okay, so the limit as this goes to infinity, think about x getting bigger and bigger and bigger and bigger.
It's getting smaller.
It's getting small. I mean, think of x getting larger here, right? It's getting smaller. Exactly. When x goes to infinity, this is a huge fraction. What is it getting really close to?
0.
0. So the limit is 0. That is our y asymptote. That's how you find y asymptotes, is finding the limit as x goes to infinity. What if I change this to y equals 1 over x plus 1? What if I changed it now to y equals x plus 1? Would my x asymptote change? No. Right. This is still, so as the limit as x goes to infinity of 1 over x plus 1, what does that equal to? 1, right. Shabazz, how do you get 1 when you put x to infinity right here?
You go by the shift.
It's based on the shift, right?
Y equals.
But moreover, as 1 over x goes to infinity, that goes to 0, but you're still left with your 1, right?
That's Y.
But it is a part of the shift. Shabazz has a point. When you shift this, that's your y equals 1. But we still also have x equals 0, because we still have undefined at 0. And now this would be your graph. Any questions? Okay. So, really quickly, if everybody's done writing this down, if anybody's still writing this down, raise your hand. Okay, I'll give you a couple seconds. I'm going to show, for the rest of you, I'm going to show you this, and I'm going to call on people or ask people to tell me what the asymptotes are of your memory graphs.
It's a recording.
I know. I'm going to put this online too, of us talking about these. More time for anybody?
So if I was making flashcards, should I make them off that one or the one we did for homework last night?
This one will be fine. Just by looking at these, do these have asymptotes? Oh, let me move this up. Do these have asymptotes? No, nothing is being approached. There's nothing undefined about 2 or 1. What about, or 3, right? What about 4? What are 4's asymptotes? Right. X equals 0, y equals 0. That's what we just did, right? Exactly. What Sam's noticing is it mirrors right here, and it matches where it's undefined at, where the range and domain are undefined at. Sometimes you'll have an asymptote. Not always, but sometimes. Okay? Any asymptotes here? Right. Another one at x equals 0. Y equals 0? Right. Because the graph is approaching right there. What about number 6? No asymptotes? Number 7? No. A square root gets larger and larger and larger and doesn't have any limit on it, right? 8? X equals 0? Or y equals 0? And then what about this ln? Right. X equals 0.
Why is it an X?
Because horizontal lines our y equals. Okay? It's a constant at 0. Okay? Does this have any asymptotes? No. Right? Okay. Let's see. Let's make sure. Okay. I actually have one last thing. It shouldn't take long. I don't want to forget it. Or you know what? I'll cover that Monday because I have one more thing to cover, but it's really simple. It's going in the reverse order of graphing polynomials. It's looking at a graph of a polynomial and making the function. Really simple stuff. I'll talk about it Monday. Okay. Right now, let's get started on